Hello everyone, section 11.3, areas of polygons. So we have this formula for a rhombus or a kite, works for both, and it's simple, it's nice. Half diagonal 1 times diagonal 2 gets you the area of any rhombus or any kite. Example 1, find the area of each rhombus or kite. So we have diagonal 1 is 5, diagonal 2 is 11. So half 5 is 2.5 times 11. 2.5 times 11. The area here equals 27.5 units squared or square unit. Nope, sorry, feet. We know the units in this one. Square feet or feet squared. Part B, diagonal 1 is 24, diagonal 2 is 10. Half 24 is 12. 12 times 10 is 120. 120 square millimeters or millimeters squared. Example 2. Before we get into example 2, we have some terminology that you need to become familiar with. Normally I don't go through the terminology on these videos, but it's important. We have the center of the polygon. The radius of the polygon would be PM or PN. Those are the radii, so from the center to a vertex. And then we have this new term that you are probably unfamiliar with, and I've heard it pronounced two different ways. I've heard it pronounced apothum, and I've also heard it pronounced apithum. It doesn't matter to me which way you pronounce it, as long as we use it correctly. We also have the central angle of the polygon, which is MPN. So from vertex to center back to a different vertex to the next adjacent vertex is the central angle. And we're going to be using all of those to find different areas in this section. All right, example 2. In the diagram, polygon A, B, C, D, E, F, G, H, J, K, we skip over I because I's are easily confused with L's, is a regular decagon inscribed in circle P. Find the measure of each angle. So we want to find the measure of angle KPJ, because this is a decagon. There are 10 congruent sides as we go around, making 10 congruent central angles intersecting those sides. So KPJ is 1/10 of 360. So 360 divided by 10 is 36 degrees. LPK, LPK, because KP and JP are congruent, this is isosceles. LP is perpendicular to the base of the isosceles, making LP an angle bisector. So this is 18 degrees. LJP, well, we have a right triangle. This is 18, this is 90. So this is remainder of 90 minus 18. So 90 minus 18, 72 degrees. So there's example 2. Then we have this nice formula for the area of any regular polygon. So the area of any regular polygon is 1/2 A. A is the apithum or apothum, and capital P is perimeter. So 1/2 apothum times perimeter, or 1/2 A times NS, N being the number of sides and S being the length of that side, of each side. So example 3. We have a regular hexagon is inscribed in the circle with a diameter of 32 units. Find the area of the hexagon. So if the diameter is 32, then the radius is 16. And we're going to find the apithum, and we're going to find the length of the sides using right triangles. So if we think back to what we just did in example 2 to find the central angle, we need to find the measure of this angle right here. So there are 12 of those going around because there are 6 sides. So there's 12 of them. So 360 divided by 12 gets us 30 degrees, making this a 30, 60, 90 right triangle. So if this is 16, this is 8. If this is 8, this is 8 square root 3. So the apothem or apothem is 8 square root 3, and the length of a side is 16. Area equals 1/2 AP, 1/2 8 square root 3. 16 times 6. 16 times 6, 96. Find the area. So let's go to the, we're going to leave it in simplest radical form. 96 divided by 2 is 48. 48 times 8 is 384 square root 3 units squared, or square units. If we do go rounded, and times 3 square root, you get approximately, and this would all depend on the directions on the quiz or test, 665.12 units squared. Okay? So on the quiz or test, it will tell you either simplest radical form, exact, or rounded, nearest tenth, nearest hundredth, whatever. Okay, so example 4. We have a mirror is shaped a regular nonagon. Nonagon is 9 sides, each with 6-inch sides. What is the area of the mirror? So what we don't have is apothem, right? Perimeter is easy. 6 times 9 is 54 inches. We have the perimeter. What we need is apothem. So this is a little bit different. So this is now 3, not 6. Okay, a little bit different because this one's not going to be a special right triangle. Or is it? Let's see. There's 18 of these, right? 9 sides. So there's 18 of these. 360 divided by 18 is equal to 20 degrees, which our book actually does label as a special right triangle, 20, 70, 90. But we don't have any special formulas for it. But what we can do is we got 3, we have A, and we have this angle. 3 is opposite, A is adjacent. That's tangent. Tan 20 degrees equals 3 over A. A equals 3 over tan 20 degrees. And I'm going to leave it like that for now, actually, because area of this nonagon is equal to 1/2 AP, 1/2 3 tan 20 degrees times 54. Half of 54 is 27. 27 times 3 is 81, divided by tangent of 20 degrees, approximately So actually, it's exactly. We'll leave it as exact and then approximate. I'll give you both. It's 81 tan 20 degrees inches squared, or approximately 222.55 inches squared. Okay, so that is example 4. Example 5. I'm going to be filling in these blank spaces to this diagram. So example 5, we're going to fill in each of these parts. We know some of the pieces is AC is 20, BD is 15. Those aren't in the diagram, but we are going to use them. Area. So area of any parallelogram is base times height. So 12, which is our height. 12.5 times 12. 12.5 times 12 is 150 units squared. So that's the area of ABCD. Okay. We want to find the area using a slightly different formula. We're going to go 1/2 diagonal 1 times diagonal 2. That was this formula from the beginning of the unit. Okay, so 1/2 diagonal 1 times diagonal 2. Diagonal 2 is 15. Diagonal 1 is 20. Half 20 is 10. 10 times 15, 150 units squared. Good thing that we're getting the same answers because we're finding the area of the same object. The object hasn't changed, we're just doing it different ways. Oh, now we're going to do 4 times 1/2 of something. Well, what are there 4 of? There's 4 triangles that make up this rhombus. So we're going to find the area of one of the triangles and multiply times 4 because they're congruent triangles. Not only are they congruent, but we remember from our unit on quadrilaterals that the diagonals of a rhombus, are perpendicular. So this is a right triangle. This is 7.5. This is 10. So the area 4 times 1/2 of 7.5 times 10. Half of 4 is 2. 7.5 times 10 is 75. 2 times 75? 150 units squared. Again. Example 6. Find the area of the figure. Okay, in order to find the area of this figure, I suppose we could try to find the height of the figure out here. By extending, it's going to be probably too hard for us to do. But this is a right triangle. Blank 4, 5. It's Pythagorean triple. 3, 4, 5. 3, 4, 5. I now know the lengths of the 2 diagonals. The area of the rhombus is equal to 1/2 diagonal 1, diagonal 2. 1/2 diagonal 1 is 8. Diagonal 2 is 6. Half 8 is 4. 4 times 6 is 24 units squared, or square units. Example 6. Example 7. Okay, find the area of each kite. So we're told it's a kite, so we know that 1/2 diagonal 1 times diagonal 2 applies. Diagonal 1 is 6. Diagonal 2 is 6. So area here is half of 6 times 6, which is 18 meters squared. Okay. Here in part B, diagonal 1 is 8, diagonal 2 is 6. Area equals 1/2 8 times 6 equals 24 square feet. Part C, we're going to have to count spaces. All right, 1, 2, 3, 4, 5, 6. Diagonal 1 is 6. Diagonal 2, 1, 2, 3, 4, 5, 6. Again, the area, 1/2 6 times 6, just like in part A. It's 18. This time it's units squared. We don't know what the length of each of these units are. Okay. Part D. Okay. So this is 2. This is 2. Find this length here. It's isosceles. It's a right triangle. This is 2 square root 2. So I'm going to write that over here. QS is equal to 2 square root 2. I'm going to take that out of my diagram because now we want to find the length of RT. Okay, RT is the hypotenuse of this triangle. 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so RT is 5 square root 2. So the area is equal to 1/2. Diagonal 1 is 2 square root 2. Diagonal 2 is 5 square root 2. Half of 2 is 1. Square root 2 times square root 2 is 2. Times 5 is 10 units squared, or square units. Part E, we know that this diagonal is 9 square root 2, making, and you can see in the diagram, so I didn't erase it very well, making this 45, 45, 90, making this 9, this 9. We're told that this is 6, so if this is 6, we know one of the diagonals of a kite is always bisected, the other one is not. So if this one's not being bisected, then this one is. Okay, so now our area is equal to 1/2. Diagonal 1 is 18. Diagonal 2 is 15. Half 18 is 9. 9 times 15 is 135 meters squared, or square meters, for part E. Example 8. Find the area of each rhombus. Again, it's the same formula, 1/2 d1 times d2. Diagonal, so area equals 1/2. Diagonal 1 is 40. Diagonal 2 is 60. Half of 40 is 20. 20 times 60 is 1, 2, 0, 0, 0. 2 zeros. 20 times 60. 1,200 square feet, or feet squared. I know diagonal 1 is 6. Okay, area equals 1/2 6. We're going to figure out what diagonal 2 is. I'm going to draw in diagonal 2. It's a rhombus. It's a right angle. This is 3. 3 blank 5. 4. It's a special right triangle. It's a Pythagorean triple. So diagonal 2 is 8. Half 6 is 3. 3 times 8, 24 meters squared. Part C. Draw in RT here. And I'm going to draw in this right triangle right here. This is 3 by 3. Kind of right, 1, 2, 3, yep, 3 by 3. So RT is equal to 3 square root 2. Erase that so that we can find QS now. QS, let's draw in this right triangle here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 by 5. Making QS equal to 5 square root 2. So area equals 1/2 3 square root 2 times 5 square root 2. Square root 2 times square root 2 is 2. Half of 2 is 1. 3 times 5 is 15. The area here is 15 units squared, or square units. That was part C. Part D. 45, 45, 90. This is 3, and it's a rhombus. 3, 3, 3, 3. Which makes it actually a square as well. If I want, I could do 3 square root 2 as my side lengths, square that and get 9 times 2, or 18. So I know the area is going to be 18. Well, let's find it the other way. 6 times 6, 1/2. 6 times 6. Half of 6 is 3. 3 times 6 is 18 centimeters squared. Okay, which again, since I know it's a square, 45, 45, 45, 45, and 45 is 90. This is a square. Square 3, you get 9. Square 2, square the square root of 2, you get 2. 9 times 2 is 18. So finding the area 2 different ways. Part E, again, right angle, 4. This is a 30, 60, 90. 30 here. If this is for the short leg, the long leg is going to be 4 square root 3, 4 square root 3 here. So diagonal 1 is 8, diagonal 2 is 8 square root 3. Area equals 1/2. Diagonal 1 is 8, diagonal 2 is 8 square root 3. Half of 8 is 4. 4 times 8 is 32. Square root 3 meters squared this time. And part F. Again, we have a 30, 60, 90. If this is 8, this is 8 inches. This is the long leg. To go from long leg to short leg, we divide by square root 3. I'm going to leave it as 8 over square root 3, knowing that in reality it's 8 square root 3 over 3. Area equals 1/2. Diagonal 1 is 16. Diagonal 2 is 16 square root 3 over 3. So half of 16 is 8. 8 times 16 is 128 square root 3 over 3 inches squared. And that is the final part of example 8. Example 9. Find the measure of each central angle for the figure. How do we do that? Well, we're going to take the number of sides divided into 360. So 360 divided by 4 is 90 degrees. 360 divided by 5. 360 divided by 5 is 72 degrees. And 360 divided by 12 is 30 degrees. Now we're going to work backwards. If we know what the central angle is, in example 10, the measure of the central angle of a regular polygon is given how many sides are there. 360 divided by what is equal to 60 degrees. So 360 divided by 60 is going to be 6 sides. So n equals 6. N equals 360 divided by 40 is 9. And 360 divided by 14.4, I have that off the top of my head, but it's going to be a nice number. 25 sides. 25 gone. Example 11. A portion of a regular hexagon has an apothem and radii drawn. Find the measure of each numbered angle. So it's a hexagon, so it's got 6 sides. If it's got 6 sides, it's 360 divided by 6. Measure of angle 1 is 60 degrees. 360 divided by 6. Angle 2 is half of that. Measure of angle 2 is 30 degrees. 30, 60, 90. Measure of angle 3 is 60 degrees. Find the area of each figure. Okay. A regular octagon with sides 5 inches and the apothem is 3 inches. So area equals 1/2 AP. 1/2 A is 3. Perimeter octagon is 8 times 5, 40. Half of 40 is 20. 20 times 3 is 60 inches squared, or square inches. Part B, a regular polygon with 20 12-inch sides and a 37.9-inch apothem. We have everything we need. Area equals 1/2 AP. 1/2. The apothem is 37.9. And the perimeter is 20 times 12. 240. Half of 240 is 120. 120 times 37.9. And we get 4,548 inches squared. Part C, an equilateral triangle with an apothem of 4 in simplest radical form. So I'm going to do a quick sketch over here and you'll see how we can do this one pretty quickly. The apothem is 4, making a right angle here. 4 centimeters. What we need is this side here times 6 to get our perimeter. Okay? To get this side, we need this angle, half of the central angle. Well, we know how to find the central angle from up here. 360 divided by 3 gets us 120, and 120 divided by 2 gets us 60. So this is 60, this is 30, this is the short leg, this is the long leg, 4 square root 3, 8 square root 3 is the entire side. Perimeter then is 24 square root 3. So area equals 1/2 AP. 1/2. The apothem is 4. Perimeter we just calculated to be 24 square root 3. 12 times 4, 48. Square root 3 centimeters squared. And this one says in simplest radical form. Part D does as well. A regular hexagon with side 8 meters in simplest radical form. Now, I'm not going to redraw this one because I've got one up here. Sides 8 meters. Since it's a hexagon, these angles don't change for any regular hexagon. So we care, it's a 30, 30, 60, 90, right triangle again. This is going to be 4, because it's half of the 8. This is going to be 4 square root 3, which gets us area equals 1/2 AP. 1/2. The apothem we just calculated is 4 square root 3. And the perimeter is going to be 8 times 6. 48. And 2 times 48. 96 square root 3 meters squared. And so to part D. Part E. So a regular hexagon with side 18 feet. A radius is 23.5 feet. We want to find the area rounded to the nearest 10 feet. So with a regular octagon, I'm just going to draw a cross section of some of the sides here. Radius 23.5. One side is 18. Draw in apothem. This becomes 9. Find this. I'm going to use Pythagorean theorem. I'm not going to do right triangle trig. So I don't even need the angle measures this time. So 23.5 squared minus 81 is 471.25. Square root that. This is 21.71. 21.71. So area equals 1/2 AP. 1/2 21.71. Perimeter 18 times 8. 18 times 8 is 80. 144 times 21.71 divided by 2, approximately equal to 1,562.997. But we want rounded to the nearest 10 feet. So that's here. So we're going to do 1,560 feet squared or square feet. That's example 12. Part E. Example 12, part F. An equilateral triangle with an apothem 8 in simple stratical form. So again, this time I'm giving you the apothem. It's 8. This is still 60. This is still 30. So this is 8 square root 3, making this 16 square root 3. Area equals 1/2 AB. 1/2 A is 8. Perimeter 16 times 3 is 48 square root 3. 4 times 48, 192 square root 3 centimeters squared. Part G, a square with a radius of 5 square root 2 feet in simple spherical form and rounded to the nearest tenth. So we're going to do both. Two different ways we can do this. This is 5 square root 2. Then this is 5. This is 5. 10. Area is equal to 100 feet squared or squared feet, which is simple spherical form and rounded to the nearest tenth. Another way of doing it. This is 10 square root 2. So if this is 10 square root 2, then these are 10. Another way of doing it, if this is 5 square root 2, this is also 5 square root 2. 1/2 5 square root 2 times 5 square root 2 is another way of doing it. 1/2 5 square root 2 times 5 square root 2. Square root 2 times square root 2 is 2. Divided by 1/2. I'm sorry, these are tens, not fives. 10 square root 2's, 10 square root 2's. Square root 2 times square root 2 is 2. Half of 2 is 1. 10 times 10, again, gets us that 100 square feet. So at least 3 different ways to solve part G here. Part H, a regular hexagon with a radius of 3 square root 3 meters. And I'm going to come back to this picture again, instead of redrawing it. This time the radius is 3 square root 3 meters. So if the radius is 3 square root 3, then the short leg is 3 square root 3 over 2. It's half of that. And the apothem is 3 square root 3 over 2 times the square root of 3. So square root 3 times square root 3 is 3. 3 times 3 is 9. This is 9 over 2. So we now have everything we need to solve the problem. Area equals 1/2 AP. 1/2. We calculated the apothem is 9/2. Perimeter is going to be 3 square root 3/2 times 12. So 12 divided by 2 is 6. 6 times 2 is 18 square root 3. Half of 18 is 9, 81. So we got 81 square root 3/2 meters squared. That's simplest radical form. And rounded to the nearest tenth, 81 times 3 square rooted divided by 2, 70.1 meters squared are our two answers for example 12 part H. Example 13. A regular octagon with the center at the origin has a radius of 4. So V1 is at 4, 0. Is graphed on the coordinate plane. So we're putting this regular octagon onto a coordinate plane. We're going to be able to use the coordinate plane to answer a bunch of these questions for us. Like part A, which is find the coordinates for V2. Well, V2 lies on the line y equals x. So its x and y coordinates are always the same, right? This is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. It's a little smaller than 3, 3. Okay? So it's not at 3, 3, but it's near it. This is x, comma, y. But we could call it x, comma, x or y, comma, y. We're going to use the distance formula or the Pythagorean theorem or however you want to look at it because they're all the same to find the coordinates for V2 to the nearest tenth. Okay, so we know that if this is x and this is y, so distance equals square root of x squared plus y squared. Okay. Well, we know the distance is 4. We know O to V2 is the same as O to V1. X squared and y squared, well, this is x squared and x squared. So this is 2x squared. Square root of 2 doesn't simplify, but the square root of x squared does. This is 4 equals x square root 2. X equals 4 over square root of 2. X equals 4 square root 2 over 2, or 2 square root 2, which means that y equals 2 square root 2. So the coordinates are 2 square root 2, comma 2 square root 2, or we want it rounded to the nearest tenth, 2.8, round to the nearest tenth, yep, 2.8, comma 2.8. Okay, which makes sense because originally we said it was really close to 3, 3. It's a little short of 3, 3. So 2.8, 2.8. All right, we're going to use the coordinates of V2 and the formula, 1/2 base times height, to find the area of this triangle, which you can see is kind of highlighted, which is V1, O, V2. Find the area of this triangle. Find the area of this triangle. The base is 4. The height we just calculated 2.8 or 2 square root 2 to the nearest tenth. So area equals 1/2 base 4, height 2 square root 2 or 2.8. Half of 4 is 2, so 4 square root 2. $5.7. Do we have units here? No. Units squared. Okay. Approximately, sorry. Approximately 5.7 units squared. We're going to use our answer that we just came up with here in part B to find the area of this octagon to the nearest whole number. Well, how many of these triangles are there? If it's an octagon, there are 16. 1, 2, 3, 4, 5, 6, 7. I'm sorry, there's 8 of them because we have, this is one side. So there's 8 of these. So times 8, area of the octagon is equal to 8 times 4 square root 2 times 5.7, 32 square root 2, or approximately 45. Round to the nearest whole number, it's 45 units squared. 7 times 8. If we do the 5.7, which it does say use our part B answer, so I'm using the 5.7. It actually does round up to 46. Sorry. I shouldn't have used the 4 square root 2. Because we were using a rounded number, which is usually a big no-no, but I'm following the directions here in example 13. Round it to the nearest tenth and then use those answers throughout. Okay, so that was example 13, part C. Example 14. Find the area of the triangle if each square has an area of 10. So this is 10 centimeters squared. So if that's 10 centimeters squared, then the side is square root of 10 centimeters. And this is square root 10 centimeters. And this is square root of 10 centimeters. Square root of 10 centimeters. Square root of 10 centimeters. Okay. Let's throw the height in here. Could go the Potham root. Let's do 1/2 base times height. It's 5 square root. Sorry. This is square root 10 over 2. Now, and this is 60 degrees because it's equilateral. Squares are all the same, so it's equilateral, 60, 30. So it's the short leg, long leg, so square root of 30 over 2. So the area of the triangle is 1/2 base times height. 1/2 base is square root 10. Height is square root 30 over 2. Square root 10 times square root of 30 is going to get me 10 square root of 3 over 4. Which gets me 5 square root 3 over 2. So part B, when a square and an equilateral triangle share a common side, what is the ratio of the area of the triangle to the area of the square? Leave your answer in simplest radical form. So the area of the triangle, 5 square root 3 over 2, to the square, which was 10. Okay, so 5 square root 3 over 2 over 10. It's 5 square root 3 over 2 times 1/10. 5 is square root 3 over 4, so a square root of 3 to 4 ratio. Example 15. So the regular decagon is shown inscribed in a circle, and it's got a radius of 1, so AO is a length of 1. I explain why the measure of angle AOX is 18. We've done this a bunch of times today. There are 10 sides. AOX is half of one of the central angles AOB. Okay, so there are 20 angles that are the same as angle AOX. So 360 divided by 20 is equal to 18 degrees. Okay, we're going to use our calculator. Let me turn my calculator back on here. To find the measure of AX and OX. So, and we're going to use sine to find AX. Why? Because, well, sine of 18 degrees, which is up here, is the 18, is opposite over hypotenuse. So AX over 1, multiply. AX is equal to sine of 18. So 18 sine 0.3090 is the length of AX. Cosine is going to be, we're finding OX now. OX is adjacent. So cosine is adjacent over hypotenuse. So cosine of 18 degrees is equal to OX over 1. So OX is equal to cosine of 18 degrees. 18 cosine 0.9511. And we're going to use these to continue this problem. And I'm going to write them on the top of the next page. I'm going to write AX equals sine of 18, or approximately 0.3090, and OX is equal to cosine of 18, or approximately 0.9511. Okay. Find the perimeter of the decagon. AX is half of one side, so we need to do 20 AXs. So the perimeter of the decagon is 20 times AX. Okay, so again, sine of 18 times 20 gets us approximately 6.18, and we don't have units here, so just units. Area of triangle AOB. area of triangle AOB? Well, base times height. Base is AB. AB is equal to 2 times AX. Okay. So area of triangle AOB is area triangle AOB equals 1/2. Base is 2 times AX times the height, which is OX. Okay, or AX times OX, AX is half of 2, 1, AX 0.3090, 0.9511, multiply those together, so 18 sine times 18 cosine equals 0.29 units squared. How many of these do we have? Well, it's a decagon. We've got 10 of them. So 2.9 units squared. That was example 16. That was example 15. Example 16 is, what if we don't know the number of sides? It's just any polygon, but yet it's still the exact same scenario. The radius is still 1, it's still regular, and it's still inscribed inside of the circle. Okay, so y is the measure of angle AOX, 180 divided by n. Well, AOB, measure of angle AOB, is 360 divided by n, and AOX is half of that. The measure of angle AOX is half the measure of angle AOB, which is half 360 over n, which is 180 over n. Okay, so there's part A. Part B, we're going to show that AX is equal to the sine of 180 over n. So again, this angle here is angle AOX, and that's 180 over n. And AX over 1 is going to be the sine of 180 over n. It's opposite over adjacent. So AX sine is opposite of angle AOX is equal to AX over AO. Sine of AOX is 180 over n, and AO is 1. This is over 1. This is the measure of angle AOX replaced. So we've just shown part B. We can do the exact same thing for part C. Cosine of angle AOX is equal to adjacent OX over the hypotenuse AO. Cosine of 180 over n is equal to OX over 1. That's part C. Part D. Show that the perimeter is equal to 2n times the sine of 180 over n. AX is half of AB. So perimeter is equal to n, number of sides, times AB. Perimeter is equal to n, number of sides, times AB, we already said, is 2 times AX. And perimeter, and AX is equal to the sine of 180 over N. N times 2 times sine of 180 over N, or 2N sine of 180 over N, 2N sine of 180 over N. That's part D. Part E, show that the area is equal to N times the sine of 180 over N times the cosine of 180 over N. Okay, well, the area is 1/2 AP. Area equals area of the polygon equals 1/2 AP. 1/2 A is OX. The apothem is OX. And the perimeter we just came up with is 2N sine of 180 over N. Okay. OX is cosine of 180 over N. Half of 2 is 1. Rewrite things. N sine 180 over N. OX is cosine 180 over N. Here, we've just shown part E. Example 17. Find the area of each figure. Okay, a regular decagon with a side 12 centimeters rounded to the nearest whole number. So again, I'm just going to draw part of the decagon. Sides 10. When I put in the apothem, that makes this 5. Okay. This angle here is going to be 360 divided by 20, right? 360 by 20 sides, right? Yeah, 18. Okay, and I probably should have just used this picture back here. That's the decagon, and there's the 18. Okay. So this is 18 degrees. I need the apothem. That's going to be tangent. So tan, let's call that A. Tan of 18 degrees equals 5 over A. A is equal to 5 over tan of 18 degrees. Area of the decagon is 1/2 AP. 1/2 A we just found out is 5 over the tangent of 18 degrees. And the perimeter is going to be 100. Each side's 10. It's a decagon. So half of 100 is 50. 250. So, divided by tangent of 18. Rounded to the nearest whole number, so approximately equal to 769 centimeters squared. That's part A. Part B, a regular pentagon with a radius 18 feet. Again, just going to draw in part of it. This time I know the radius is 18 feet. I remember from earlier that the central angle of a pentagon is 72, so this is 36 Okay. I'm going to need the apothem and I'm going to need the opposite. So the apothem is going to call it A, call this X. So the apothem is going to use cosine. Cosine of 36 degrees equals A over 18. A equals 18 cosine 36 degrees. X is, to find X, we're going to use sine. So it's opposite over 18. So sine of 18 degrees equals X over 18. X is equal to 18 sine of 36 degrees. I wrote that wrong. Sine of 36. So 1/2. The perimeter is going to be X times 10. So our perimeter, P, is equal to 10x or 180 sine 36 degrees. And the area equals 1/2 AP, 1/2 18 sine, 18 cosine. (36 degrees) times perimeter is 180 sine of 36 degrees, 180 sine 36 degrees. I'm going to round this to the nearest whole number. So 9 times 36 cosine times 180 times 36 sine gives us approximately 770 square feet, or feet squared. Square feet or feet squared. Alrighty. Part C, a regular octagon with radius of 10 meters. So again, this time it's an octagon. Radius is 10 meters. This angle here is going to be 360 divided by 16. (22.5 degrees). A, X, cosine 22.5 degrees. It's exactly the same steps as the previous problem. Okay, exactly the same. We've just changed the numbers. Equals A over 10. A equals 10 cosine 22.5 degrees. Sine 22.5 degrees equals X over 10. X equals 10 sine 22.5 degrees. And the perimeter is equal to 8x, octagon, 8x, which equals 80 sine 22.5 degrees. And area equals 1/2 AP equals 1/2. The apothem is 10 cosine 22.5 degrees times perimeter 80 sine 22.5 degrees, or approximately, and again this time we're rounding to the nearest tenth, 5 times cosine of 22.5 times 80 times sine of 22.5 equals 141.4 meters squared. Is the answer to part C. Part D, we have a regular dodecagon with a radius of 1 mile rounded to the nearest square mile. So this time I'm actually going to go back to what we did a few minutes ago, actually on the back side here, previous side. And we're going to show that the area of the polygon, we've already shown it. So I can use this now. And I know what n is. N. So area equals n sine of 180. Area equals n sine of 180 over n cosine of 180 over n, which is very similar to what we were just doing, just a little more simplified. So this equals, our dodecagon has 12 sides, so 12 times the sine of 180 over 12 times the cosine of 180 over 12. And again, I'm only doing this because the radius is 1. Okay, and I thought about showing you if the radius is, say, r. How does that change? Or the radius is AO. Make it an r. How does that change this formula down the bottom here? It actually adds in an r squared into the formula. But that's right. So if it's not 1, but this time the radius is 1. So 12 times 180 divided by 12 is equal to 15. So these are 15s. So 12 times sine of 15 times cosine of 15 is equal to, we don't have to round, 3 miles squared, or 3 square miles. Works out to be a nice number. All right, example 18. The Pentagon in Arlington, Virginia is one of the world's largest office buildings. It's a regular pentagon. And the length of each side is 921 feet. So 921, 921, 921, 921. Find the area of the pentagon to the nearest 1,000 square feet. So I'm just going to draw a part of it. This is 921. I need the apothem. So 921 divided by 2 is 460.5. This angle is 36 degrees. Okay, tangent is going to get us A. Tangent of 36 degrees equals 460.5 over A. A is equal to 460.5 over the tangent of 36 degrees. Okay. Area, let's slide over to this side. Area equals 1/2 AP. 1/2. Just calculated the A, 460.5 over tangent 36. 460.5 over the tangent of 36 degrees. Times the perimeter is 921 times 5. 921 times 5 is 4,605. 4,605. The rest is just multiplying this out. So divided by 2 times 460.5. That divided by tangent of 36 degrees is equal to, approximately equal to, 1,459,379.5 square feet. And this says round to the nearest 1,000 square feet. So we're going to round this to the nearest 1,000. So rounding down to here. So approximately 1,459,000 square feet, or feet squared. It's the answer to example 18. That's the end. Thank you very much. Bye.